Welcome to solverfy.
To determine if the sample sizes are large enough for the normal approximation of the difference in sample proportions, we can check a couple conditions. First, that both sample sizes are sufficiently large, where both sample sizes are the sample sizes for airport screeners and the rest of the federal workforce, respectively. And the expected number of successes and failures in each sample are sufficiently large, and typically that's greater than or equal to 5. So given that the sample size for airport screeners is 75 and for the federal workforce is 125, we need to check the conditions for both groups. So for airport screeners, the p hat would be 0.29, that's the proportion, the sample proportion is 29%. And so the expected number would be 75 times 0.29, which is 21.75, and that's greater than or equal to 5. And the expected number of failures would be 75 times 1 minus 0.29, and that is 53.25, which is greater than or equal to 5. So we're good for airport screeners, and for the rest of the federal workers, p hat is given as 4.5%, so that's 0.045, so the expected number is the expected number of successes would be 125 times 0.045, and that is 5.625, which is greater than or equal to 5. And the number of failures is 119.375, which is greater than or equal to 5. Since all conditions are met, both sample sizes are reasonably large and the expected counts are sufficient, we can approximate the distribution of the difference in sample proportions with a normal distribution. Number 2, the null hypothesis is that the injury rate for airport screeners is not more than 10% larger than that of the rest of the federal workforce. So p hat 1 minus p hat 2 is less than or equal to 0.10. And the alternative is that the injury rate for airport screeners is more than 10% larger than that of the rest of the federal workforce. The significance is 0.05. The decision rule would be to reject the null hypothesis if p is less than 0.05, if we're using the p-value rule. And the test statistic is a z-test statistic which is calculated as the difference between the p hats minus the hypothesized over the standard error. And the standard error is the square root of the pooled sample proportions, which would be give myself some space here. pooled standard, the pooled proportion would be the 75 times 0.29 plus the 125 times 0.045 over 75 plus 125, which is 0.136875. And then the standard error is going to be the square root of the pooled sample proportion times 1 minus the pooled times 1 over n1 plus 1 over n2, and I'm just going to go right to a calculator for that. As 0.0502. So our test statistic is going to be 0.29 minus 0.045 minus 0.10 over 0.0502. And that is 2.89. That would be the test statistic. The p-value then from a z-score of 2.89 at a 5% level of significance and being one-tailed is 0.0019. And so the conclusion would be to reject the null hypothesis in favor of the alternative. There is sufficient evidence to suggest that the difference in the difference of the proportions is greater than 0.10.